Two shovels, identical design. One works. One kills the soldier using it. America copied Germany's shovel, measured every dimension, photographed every feature, recreated the exact same tool. But they changed one thing, one tiny hidden component. And that single change sent American soldiers to their graves while German soldiers survived. What did they miss? Like this video right now and stay till the end. I'll show you exactly what American engineers got wrong. Tunisia, North Africa. March 1943. A young American private named Danny Webb crouches behind a burned-out German half-track. His heart slams against his ribs. Sweat pours down his face despite the morning chill. His fingers grip the handle of his brand-new folding shovel. German artillery screams overhead. The first shell lands 50 yards to his left. Dirt and rocks explode into the air. The shockwave punches his chest. He needs a foxhole. He needs it now. Danny yanks the M1943 entrenching tool from his belt. The new folding shovel, just issued 3 days ago. He flips the blade perpendicular to the handle, twists the locking nut tight, raises the shovel overhead. He slams it down into rocky desert hardpan. The blade bites. Chips fly. Second stroke. Still holding. Third stroke. The locking nut slips. The blade folds flat against the handle. Danny stares at the useless tool. Another shell whistles in. It's closer this time. He fumbles with the nut. Sweaty fingers slip against smooth aluminum. He squeezes harder. Twists with everything he has. Sets the blade again, swings down. Fourth stroke, holding, fifth stroke. The nut gives. The blade folds. 40 feet to his right, Sergeant Morrison digs steadily into the same rocky ground. His shovel blade stays locked with every stroke. His hole gets deeper. Faster, but Morrison's shovel is different. Green paint, German markings. A captured Klappspaten, he pulled off a dead Wehrmacht soldier 2 weeks ago. Morrison is below ground level now, protected. Danny is still above ground, still fighting his own equipment. The shells keep falling. This is not a story about bad luck. It's not a story about one defective shovel. This is a story about a pattern. A flaw built into hundreds of thousands of American entrenching tools. A flaw that frustrated soldiers across 3 continents for the entire war. And it all starts with one question. Why does a shovel even matter? Here is the truth that every infantryman learns the first time artillery falls on his position. Dirt saves lives. When shells drop, when mortar rain down, when machine gun fire sweeps across open ground, there is exactly one thing standing between a soldier and death. A hole in the ground, deep enough to survive the blast. Dug fast enough to matter. In modern mechanized warfare, the ability to dig in quickly is not convenience. It is survival itself. And in early 1943, American soldiers have a serious problem strapped to their backs. What's the most reliable tool you've ever owned? Something that never failed you. Drop it in the comments. The standard U.S. entrenching tool in 1943 is the M1910. A T-handle shovel designed before the First World War, 33 years old, 22 inches long, 7 inches wide, non-folding, heavy, awkward. The wooden handle snaps under stress. The blade bends against rocks. And worst of all, it takes forever to unsling from a pack when shells are already falling and every second counts. A quartermaster officer stationed in Tunisia writes a field report that cuts straight to the crisis. The entrenching tool is one of the few items the fighting soldier will not discard, but will actually carry right into battle with him. It is probably the most useful utensil in his possession. In every new position, either advancing or retreating, it is absolutely necessary that a foxhole be dug. When foxholes are needed, they are usually needed in a hurry. And deep, the M1910 cannot deliver speed, cannot deliver depth, cannot deploy fast enough when death whistles down from the sky. Soldiers are dying because their shovels are too slow. But something strange happens across the North African battlefield in those desperate, early months of 1943. American troops watch German prisoners file past. Hands raised, uniforms dusty, equipment stripped. But every German soldier carries the same thing on his belt: a compact folding shovel. Small, light, fast to deploy. And it works every single time. Word spreads through foxholes and mess tents and field hospitals. Those German shovels are different. Better, soldiers who capture them refuse to give them up. Within weeks, the German Klappspaten becomes the most prized piece of captured equipment in North Africa. More valuable than Lugers. More valuable than binoculars. More valuable than anything except ammunition. Soldiers trade cigarettes for them. Trade rations. Trade personal items from home. Supply officers document the hoarding. I write reports up the chain of command. Something about the German shovel makes American soldiers desperate to own one. The question reaches the quartermaster corps. Why can't America build something this good? The answer comes back fast. We can. We will. We are. American engineers begin copying the German Klappspaten in late 1942. They lay captured shovels on examination tables. Measure every dimension with precision calipers. Photograph every feature from every angle. Analyze the blade curvature, the hinge mechanism, the handle construction, the folding positions. They understand exactly how the German design works. They begin manufacturing the American version, the M1943 entrenching tool. If you're learning something new, hit subscribe. We dig into World War II details other channels miss. The German Klappspaten is a masterpiece of practical engineering. Here is how it works. A blued stamped steel blade hinges on a folding tube. The tube rivets to a solid hardwood handle. The entire assembly collapses to just 18.5 inches, small enough to ride on a soldier's belt, light enough to forget until the moment he needs it. 3 positions available. Blade fully extended at 180 degrees for standard spade work. Digging foxholes, moving dirt, basic entrenching. Blade perpendicular at 90 degrees for pick and hoe use. Chopping through roots, breaking frozen ground. Hacking into rocky soil. Blade folded at 0 degrees for compact carry. The hinge is solid. The blade is tempered steel, built to take abuse. The handle is secured with steel pins that will not work loose. But none of that is the genius. The genius hides at the junction between blade assembly and handle. A deep red-ribbed collar made from Bakelite. Bakelite is an early thermosetting plastic. Hard as steel when fully cured. Resistant to temperature extremes from -42 over 120 degrees. Impervious to moisture and corrosion, and covered with deep-ribbed grooves. A soldier wraps his hand around that collar. Those grooves bite into his palm, even with frozen fingers, even with muddy hands, even with sweat pouring down his wrists. The grooves provide grip. He twists hard. The collar threads down tight. The blade locks rigid, and it stays locked. Through heavy impacts, through frozen ground, through desperate swinging when shells are falling and a soldier needs depth fast, the Bakelite collar holds. German troops prove the Klappspaten across Poland, France, Russia, North Africa. It digs trenches in frozen Stalingrad earth at -40 degrees. It chops roots in French forests. It survives, drops from trucks, impacts against boulders. Temperature swings that would destroy any lesser tool. By 1943, the Klappspaten is legendary. American engineers study the German shovel with intense focus. They understand the brilliance of the design, the compact size, the 3-position blade, the robust construction. They set out to build an American version, the M1943 entrenching tool. On paper, it is nearly identical to the German original. Folding blade affixed to a hilt. Hilt riveted to a wooden handle roughly 16 inches long. Blade locks at 180 degrees for spade work. Locks at 90 degrees for pick work. Folds to 0 degrees for compact carry. Same concept, same dimensions. Same functionality. Production begins in 1943. Ames Company. American Fork and Hoe. Wood Company. Multiple manufacturers stamp out hundreds of thousands of units under desperate wartime pressure. The M1943 ships to North Africa, to Europe, to the Pacific. American soldiers finally have their folding shovel. But the engineers made changes. Small changes. Changes that seemed insignificant during the design phase. Changes that streamlined production for an army racing to equip millions of soldiers. They replaced the German Bakelite locking collar with an aluminum threaded nut. Smaller diameter, thinner walls, softer metal, smooth surface instead of ribbed grooves. The aluminum nut looked similar from the outside. It functioned when first tightened in the factory. It simplified manufacturing. It lowered cost per unit. It seemed like a reasonable trade-off. It was a catastrophic mistake. Why do you think they made this change? Wrong answers only. Drop your theory below. North Africa. Summer 1943. Temperature climbs past 115 degrees. Private First Class Robert Chen crouches in a shallow depression behind a rocky outcrop. His unit is pinned down. German mortars have their position bracketed. Explosions walk closer with each salvo. He needs deeper cover. He needs it now. Chen pulls his M1943 from its canvas carrier, twists the aluminum locking nut, sets the blade at 90 degrees. The ground is hard. He needs pick mode. He raises the shovel, brings it down into sun-baked hard pan. First stroke, blade bites. Progress, second stroke. Holding, third stroke. The aluminum nut slips. The blade folds flat. Chen's stomach drops. He can hear the next mortar rounds leaving the tubes. He fumbles with the nut. His fingers are slick with sweat. The aluminum is smooth. No grip. He squeezes harder, twists with all his strength, sets the blade again, swings down. 3 strokes. The nut gives. The blade folds. Chen looks around desperately. 20 meters away, Corporal Williams digs with a German shovel he captured last month. His blade stays locked. His hole deepens with every stroke. Williams will survive this barrage. Chen is not sure he will. What is happening inside these two shovels? Why does the German lock hold when the American lock fails? The answer is invisible from the outside, but it makes all the difference. The German Bakelite collar provides massive surface area for hand tightening. Deep ribbed grooves give fingers exceptional purchase in any condition. The hard thermoset plastic does not flex under pressure, does not deform, does not give. A soldier grips that collar with his full hand, cranks down hard. The ribs bite into his palm. The threads engage completely. The mechanism locks absolutely solid, and it stays locked, even under tremendous leverage. Even when the blade slams into frozen earth. Even when physics tries to fold that blade with every desperate stroke. The Bakelite collar was designed with massive safety margin, built to handle far more stress than normal use would ever create. The American aluminum nut is different. Smaller diameter means less mechanical advantage when tightening. A soldier's fingers cannot generate the same torque, cannot achieve the same tightness. Thinner walls mean the nut flexes under impact. When the blade hits hard ground, the nut gives microscopically. The blade shifts, the lock loosens. Softer aluminum means the threads degrade with repeated use. Each tightening cycle grinds metal against metal. Each impact chews the threads a little more. Smooth surface means sweaty fingers slip. Cold fingers slip. Dirty fingers cannot find purchase. And here is the fatal problem. When you swing a shovel blade locked at 90 degrees into hard ground, you create tremendous leverage on the locking mechanism, Every impact tries to fold that blade flat. The lock must resist completely. The German Bakelite collar resists. That is what it was built to do. The American aluminum nut cannot, not reliably, not consistently, not when soldiers need it most. Learning something new, hit like right now, helps this story reach more people who care about real history. The problems multiply in field conditions. Desert environments destroy the aluminum nut faster than anyone anticipated. Fine sand infiltrates the threads. North African grit works its way into every mechanism, every joint, every moving part. Each time a soldier tightens the nut, sand particles grind between aluminum and steel. Corrosion attacks next. Aluminum and steel together create electrochemical reactions in the presence of moisture. Sweat, morning dew, occasional rain. The threads begin to seize. The metals begin to bond. Temperature cycling finishes the job. North African days push past 120 degrees. Nights plummet below freezing. The aluminum nut and steel shaft expand and contract at different rates. This differential movement loosens threads during scorching days, jams them solid during freezing nights. Within weeks of issue, many M1943 shovels become completely unusable. The aluminum nut seizes to the shaft. It will not turn in either direction. The blade locks at whatever position it happened to be in when corrosion set. Soldiers spend hours trying to free corroded mechanisms. They bang the nut with rocks, pry with bayonets, soak in motor oil. Nothing works. A collector examining original M1943 shovels decades later describes what he finds. The nut is made of soft aluminum alloy that grinds and chews itself to pieces. When corrosion gets into the threads, they are done. They may as well be welded. The same defect, the same failure. Shovel after shovel, unit after unit. For the entire war. Soldiers adapt. They have no other choice. They learn to avoid the 90-degree position entirely. The pick mode that should chop through roots and frozen ground becomes useless. The aluminum lock cannot handle the leverage. They default to 180 degrees, standard shovel mode, less effective on hard ground. But at least the blade usually stays in place. They stop adjusting the nut whenever possible. Each tightening cycle risks stripping the threads further. Better to work around the problem. And whenever they get the chance, they find German shovels. When American units overrun German positions, soldiers grab Klappspaten before anything else. Before weapons, before food, before souvenirs. They throw their M1943 tools in ditches, in rivers, in bomb craters. They never look back. The enemy's shovel works better than their own. The irony burns like acid. American engineers had a perfect blueprint. They measured the Klappspaten to the millimeter, photographed it from every angle, understood exactly how every component functioned. They copied everything visible and changed the one hidden thing that made the whole design work. What other World War II equipment should we investigate? Drop your ideas in the comments. Why did American engineers make this choice? The question demands an honest answer. They were not stupid. They were not lazy. They were crushed under impossible pressure. In 1942 and 1943, the United States fights a global war on multiple fronts. The Army expands from hundreds of thousands to millions of soldiers. Every soldier needs equipment. Every piece of equipment needs manufacturing capacity. The list is endless. Rifles, ammunition, grenades, mortars, artillery shells. Tanks, trucks, jeeps, aircraft, ships, boots, uniforms, helmets, canteens, mess kits, medical supplies, tents, blankets, entrenching tools. Bakelite requires specialized equipment. Thermosetting plastics need precise temperature control during curing. The process takes time, takes expertise, takes manufacturing facilities that might be desperately needed for something else. Aluminum nuts can be machined on standard lathes. Any factory can produce them. Faster, cheaper, simpler quality control. The engineers faced an impossible choice. Perfect tools for some soldiers, or adequate tools for all soldiers. They chose scale. They chose speed. They chose getting shovels into hands as fast as possible. The M1943 locking nut worked in factory conditions. It tightened properly under controlled testing. It held the blade steady during quality inspections. Factories are not foxholes. Desert sand does not infiltrate threads in Ohio plants. Temperature does not swing 100 degrees in New Jersey warehouses. Soldiers do not slam tools into rocky ground with desperate force during quality control. Field conditions reveal weaknesses that controlled testing never finds. German engineers spent years perfecting the Klappspaten before 1938. Years of testing. Years of refinement. They learned that the lock is everything. American engineers had months. They assumed a simpler mechanism would work well enough. That assumption cost soldiers dearly. This pattern repeats across military equipment. Consider the jerry can. The German Wehrmacht canister is a 20-liter fuel container designed in the 1930s. Welded seams that never leak. A three-handle design for easy passing. An air pocket that lets full cans float. Recessed welds protected from damage. American forces encountered jerry cans in North Africa. Same story as the shovel. They recognize superior design. They copy it. But American manufacturers use rolled seams instead of welded seams. Faster production, lower cost. American jerry cans leak. German jerry cans do not. Same pattern. Copy visible features. Change hidden details. Discover problems in the field. The blade shape is visible. Anyone can copy that. The hinge mechanism is visible. Easy to replicate. The locking collar material is hidden. The thread design is hidden. The grip surface is hidden. Those invisible details separate equipment that works from equipment that fails. German engineering in the 1930s emphasized overbuilding, massive margins for worst-case conditions. American wartime manufacturing emphasized speed and scale. Adequate equipment for everyone, fast. Both approaches made sense. But somewhere in the gap between them, soldiers struggled with locks that would not lock while shells fell around them. Let me show you two soldiers. Same war, same desperate need. Different shovels. Eastern Front, February 1943. Temperature -30 degrees. A German grenadier named Hans presses himself against frozen earth outside Stalingrad. Soviet artillery pounds the position. Each shell shakes the world. He needs cover, deeper cover. Hans pulls his Klappspaten from his belt. His fingers are numb through thin wool gloves. He grips the ribbed Bakelite collar. Even through fabric, he feels the grooves bite into his palm. He twists hard. The collar locks with a solid click. He raises the shovel, brings it down into frozen Russian earth. The blade bites deep. Ice chips fly. Again, again. The Bakelite collar never slips. The blade never folds. The tool does exactly what it was designed to do. 10 minutes later, Hans crouches in a foxhole deep enough to survive. The Soviet barrage passes over. He lives. Now picture Tunisia. Same month, an American rifleman named Jimmy presses against a low stone wall. German 88s bracket his position. Each shell lands closer. He needs cover. Now Jimmy pulls his M1943 from its carrier. His hands shake. Sweat stings his eyes. He twists the aluminum nut. It slips, squeezes harder, sets the blade at 90 degrees, swings down into sun-baked earth. First stroke, holding. Second stroke, holding. Third stroke, the nut slips. Blade folds. Jimmy fumbles, retightens, swings again. 2 strokes, slips again. He is still above ground when the shells land. Hans and Jimmy faced the same enemy. Artillery, They had the same need, a hole deep enough to survive. The difference was not courage, not training, not will to live. The difference was a locking mechanism. Bakelite versus aluminum. Ribbed collar versus smooth nut. One invisible component, one hidden detail. Life versus death. The M1943 remains in American service for decades. World War II, Korea, Vietnam, hundreds of thousands manufactured. Millions of soldiers issued the same flawed tool. The chronic problems never disappear. The M1951 entrenching tool attempts improvements. The M1967 tries again. Each version addresses the fundamental weakness that plagued the original. Engineers finally learn what German designers knew in 1938. The lock is everything. A folding shovel that folds when you need it rigid is worse than useless. It betrays the soldier depending on it. All the clever engineering means nothing if the lock fails at the critical moment. Modern military entrenching tools feature robust locking mechanisms. Heavy-duty collars, aggressive grip surfaces, materials chosen for field durability. The lesson took lives to learn, but it was learned. The German Klappspaten casts a long shadow. Post-war armies worldwide adopt folding shovels with robust locks. Commercial manufacturers study German specifications. Buy a quality folding shovel today, and you will find a locking mechanism built to survive abuse. Because engineers finally understood what soldiers always knew. When you need to dig now. The lock cannot fail. Here is what this story teaches. Great engineering is not about visible features. Anyone can see a blade. Anyone can copy a hinge. The obvious parts are easy to replicate. Great engineering hides in invisible details. The locking collar material, the thread depth, the grip surface, the thermal tolerance. These hidden choices separate tools that work from tools that kill. German engineers understood this. They built the Klappspaten with a locking mechanism far stronger than necessary under perfect conditions. They designed for the worst moment. American engineers faced crushing pressure. They kept visible features, changed hidden ones. They delivered a shovel that looked right and failed under stress. The M1943 was not a failure of intelligence. It was a failure of priorities. Two shovels, same blade, same hinge, same size. One saves soldiers. One fails them. The difference is invisible. The difference is everything. A locking nut made from aluminum instead of bakelite. One component, one change, one mistake. The devil hides in details nobody sees, until the moment those details decide who lives and who dies. If this story hits you, smash that like button. Share it with someone who loves real history. Subscribe if you haven't. Hit the bell so you never miss these deep dives. Comment below. Where are you watching from? What World War II stories should we cover next? These details matter. These hidden failures matter. Thanks for watching.